This is Advanced Math 7.5 Notes. That's Unit 7, Lesson 5. The title is, the lesson is actually a review of two quick review problems of stuff we've seen before. Again, it is a little hard and difficult, so you want to make sure you are paying attention. Okay, a building is on a street in San Francisco that makes a 12-degree angle with the horizontal. 15 yards down from the building, the angle of elevation is 73 degrees to the top of the building. How tall is the building? Okay, so here is our horizontal. If I can get my pencil to work. Here is the hill, and here is the building that's on the hill. Buildings still run perpendicular with the horizontal. They don't slant over with the hill. Okay, so a building's on a street in San Francisco that makes a 12-degree angle with the horizontal. Here's the horizontal. The hill makes a 12-degree angle with the horizontal. So the 12 degrees goes right in there. 15 yards down from the building, the angle of elevation is 73 degrees. So here's the building. Now 15 yards could stop here, could stop here, it doesn't matter. I found over the years that it's easier for kids to visualize it that you just go all the way down the hill. So from here to the bottom is 15 yards. Okay, so from here to the bottom of the hill is 15 yards, and the angle of elevation is 73 degrees. Now what you want to be careful with is, where does that angle of elevation go? Kids often mistakenly put it right in that corner there, and that's not correct. The 73 degrees is all of this together with the horizontal, because remember, angle of elevation is from the horizontal up. So this from here to here is, what was it, 73 degrees. Okay, how tall is the building? This is what I'm looking for. Okay, because this is going to get kind of messy, I am going to redraw this triangle here. This is the triangle that I'm going to be dealing with to find the height of the building. So I'm going to redraw that over here. Okay. Now what do we know? We know we're looking for the height, which is x. We can find this angle down here at the bottom. We can find this angle here because we know the big angle is 73. We know this little angle down here is 12, so you do 73, take away 12, and you get 61 degrees. Okay, so that's what we have so far. Oh, we also know that this is 15 yards. All right. Find the height. We still need some more information. In order to use law of sines, we need to know an angle and its matching side. So how do we do that? I know this side, which means I'm going to need to know this angle. I'm looking for this side, which means I'll need to know this angle, and I already know that angle. So how do I find this angle up at the top? I'm going to first find this angle here. Now there's different ways of finding it. You could use your z to find a little angle and then add it to go from there. Or you could use this right triangle down at the bottom. If this is 12, this is 90, then this up here has to be 78 degrees. Can you see that? 90 plus 12 plus 78 is 180. And then you can see that this here is a straight line. Straight lines add up to 180. So 180 minus the 78 is 102. Or the exterior angle equals the sum of the remote interior. 90 plus 12 is 102, if you remember that formula from back in Math 1. Okay, so now I have enough. 102 plus 61, subtract from 180 is 17 degrees. And now we have enough to solve. So I'm going to set it up. Sine of 61 over x equals, I need to use a side and an angle that I know, so that's going to be the 17 and the 15. So sine of 17 over 15. Okay, don't forget, you cross multiply. 15 times sine of 61 equals x times sine of 17. And we're going to divide both sides by sine of 17. And that's what you're going to plug in your calculator. 15 times sine of 61. Don't forget to either hit equals or close your parentheses. Divide by sine of 17. And that is 44.872 yards. And that is the height of the building. Okay, moving on to number 2. Two sides of a parallelogram are 20 centimeters and 35 centimeters. A diagonal is 40 centimeters. Find the value of the largest angle in the parallelogram. Okay, I'm going to draw my parallelogram, and we're going to kind of, as we go, review some parallelogram properties that you learned back in Math 2. Okay. Two sides of a parallelogram are 20 and 35. So I'm going to put 20 and 35. A diagonal is 40. Now, it doesn't matter if you draw your diagonal across this way or across the other way. Again, our pictures can look different, our work can even look different, but our answers should mathematically come out the same in the end. Okay, so I have 20, 35, 40. Do you see that is the triangle I'm going to end up using eventually? Excuse me. Okay, find the value of the largest angle. First thing I'm going to do is I'm going to call this angle right there x. Okay, now technically x is the only angle I have to mathematically find using all my law of sines or law of cosines. After I find x, I know the sum of the interior angles of any quadrilateral is 360, and I can go from there. Okay, so let's work with this picture right here. X, 20, 35, 40, and you can see I don't know any angles inside, so I cannot use law of sines, which I'm forced to use law of cosines, which makes sense. If I have three sides and I'm looking for an angle, I'm going to be using law of cosines. Okay, so I'm looking for x, and we could call these ABC if you would like. A, B, C, if that helps you. I'm looking for angle B, which means I'm going to start with B squared. So I'm going to start with B squared equals A squared plus C squared minus 2AC cosine of B. Okay, so why is that working out this way? Because angle B is what I'm looking for. So if angle B is what I'm looking for, side B is what I'm going to start with in my formula, B squared, and I will not use B in here, so it's going to be the A's and C's. So 40 squared, oh, really quick reminder, because I'm looking for an angle, I'm going to move all my letters over first because the angle is what I'm looking for. B squared minus A squared minus C squared divided by negative 2AC is going to equal cosine of B. All right, so let's go ahead and plug in. Cosine of B equals Where is b? b squared is 40 squared. Take away a is 35 squared. Take away 20 squared. Close parentheses, all over parentheses negative 2 times a, which is 35, times what are we multiplying? C, which is 20. Those are multiplication, not decimals. Okay, so I'm going to plug this in and then hit second, cosine second, answer at the end. Okay, so let's get this done. Parentheses, and you go ahead and plug it in on your own. And I get cosine, I'm sorry, I get 0.0178 dot dot dot. I'm not clearing it. And then you're going to hit second, cosine second, answer to get your actual angle. Second, cosine second, answer. Remember, we're looking for an angle, so we're using the inverse key. And we get 88.977 degrees. About my little negative one. Okay, 88.977 degrees. Now really this is the meat of your problem. This is all the hard work you have to do. Other than that, it's just easy adding and subtracting. I'm going to redraw my parallelogram down here. We just found angle X or angle B to be 88.977, and here's review from Math 2 on parallelograms. Opposite angle is congruent, so this one over here is also 88.977. A mistake kids make. They cut this here and they say, oh, those two angles are equal, or cut this angle in half and double, and you do not need to make another triangle. Do not. One triangle is needed, that is it. Do not cut, oh, this is what they do, I'm sorry. They cut it this way. They cut the 89.7 in half, and then they try to find this angle over here. Do not do that. First off, diagonals don't bisect angles in a parallelogram. In a rhombus, yes, not a parallelogram. Okay, so all you have to do is add these two, subtract from 360, and cut in half. Because of all four angles in here add up to 360, and those two are equal. So add them up, subtract from 360, and cut in half. Or, if you remember a property, consecutive angles are supplementary. They add up to 180. So 180 minus 88.977. Either way, hit pause, 180 minus that angle, because they're supplementary, or add these two, subtract from 360, and cut it in half because those two are congruent. Go ahead and do that now. And you end up with 91.023 degrees. And it's asking for the largest angle. Now you're not going to know the largest angle until you complete the whole problem. The largest one is this one here. So my final answer is 91.023 degrees. Now on the test they might ask for the smaller of the two angles. Who knows? Smaller, largest, you really don't know until you are done. Now you can tell my picture is not drawn to scale because this angle in the picture looks bigger than the 91.023. You really don't know until you're done. So don't go off of your picture and say, oh, that one's bigger, that's the one I'm looking for. Nah, because you don't necessarily draw your picture correctly, you didn't put your numbers in the right spots. So be careful and make sure you do the whole problem before you look for which one's largest or smallest. That is it for this lesson.